Hello friends, today we are going to solve exercise set 2.1 from CBSE 9th standard maths syllabus, chapter number 2, introduction to linear polynomials. So the first question we can see, find the degrees of the following polynomials. So the first polynomial that is given is 2x square minus 5x plus 3. Okay, now friends, degree, what do we mean by degree? We can see that in these polynomials, okay, these are algebraic expressions where there will be some variable x, y, m, n, p, okay, some variable will be there. These variables will have some power, okay, there will be some index, they will be in the exponent form. So the highest power of the variable is taken as the degree of that given polynomial. Okay, so let me write it here. The highest degree, or we can say the highest power of the variable, is the degree of that polynomial. Okay, so in this first sub question we can see that the variable is x. Okay, the variable is x, correct, and the highest power of this variable is what it is? It is 2, right? Because here we can see that 2x square, so that x has the power 2, so that is the first term. Minus 5x is the second term. Here the power of x is 1, and plus 3, that is the constant term, where we can write it as x raised to 0. Okay, so the highest power here we can see is 2. That is why the degree, therefore the degree of the polynomial is 2. That way we can write. Okay, so what is considered as the degree of a polynomial? The highest power of the variable in the given polynomial is the degree of that polynomial. Okay, so let us solve the second one. Y cube plus 2y minus 1. So again, in this polynomial we can see 3 terms are there. Out of the 3 given terms, the 2 terms are having variable. The variable is y, and out of these 2y, in that term the power of y is 1, y raised to 1, whereas in y cube it is 3, the power is 3. So that is the highest power, so that we will take as the degree of the polynomial. Okay, so let us write the answer. The variable is y, and the highest power of the variable is 3. Therefore the degree of the polynomial is 3. Okay, so that way we can answer this question. Fine. Chalo, then let us quickly write the answers of question number 3 and 4. So in question number 3 we can see there is a single term minus 9. There is no variable in it. Okay, there is no variable. Okay, fine. And if we want, we can put the variable, but then that variable will be x raised to 0. Okay, therefore the degree of the polynomial is 0. Okay, 0. Fine, that is what we can write. In number 4, 4z minus 3. So in this polynomial there are 2 terms. 4z is the first term, where z is the variable and the power of z is 1, and minus 3 is the other term, which we can write as minus 3z raised to 0. Okay, so here the highest degree is 1, highest power is 1, so which we can write as the degree. Okay, so here the variable is z, and its highest power is 1. Okay, therefore the degree of the polynomial is 1. the degree of the polynomial is 1. Okay, so that is the answer of the first question in exercise 2.1. In this question we are talking about the degree of the polynomial, and once again I will repeat, the degree of the polynomial is the highest power of the variable in that polynomial. Okay, so chalo, let us go to the second question in this exercise. The question number 2 is write polynomials of degrees 1, 2 and 3. Okay, so we, in this answer of sum number 2, there are 3 parts, so we have to write 3 different polynomials. The first polynomial should have degree 1, the second should have degree 2, and the third should have degree 3. Okay, so it is very easy, we just have to write some terms having some variable in the first polynomial. That variable should have degree 1. Okay, so for example I could write it as 4x plus 9. Okay, so here we can see that the variable is x and it is x raised to 1, so the degree of this polynomial is 1. Okay, now in the second polynomial we need the degree 2, so we could write 5x square plus 3x minus 4. Okay, something like this we can write. Here I have taken 3 terms, you could also take 2 terms, means for example 5x square minus 4, if we write like that also, then it is correct. Okay, here we can see that the variable is x. Okay, and in the middle term 3x, the power is 1, whereas in the first term 5x square the power is 2, so that is the highest power. Okay, so that degree of this polynomial is 2. Fine, then let us write the third polynomial, and this time let us choose a different variable. Instead of x, let us take p. Okay, so we could write any number we can take. Okay, let us take 11. So 11p cube minus 3p square minus 9p plus 1. Okay, so here I have chosen to write a polynomial having 4 different terms. Okay, and you can see the highest power of the variable here, the variable is p and the highest power is 3, so that is the degree of this polynomial. Okay, so that is the answer of question number 2. Okay, now question number 3, what are the coefficients of x square and x cube in the polynomial x raised to 4 minus 3x raised to 3 plus 6x raised to 2 minus 2x plus 7. Okay, so here we can see there is a polynomial having 5 different terms. We have to write the coefficients of x square, the term which is having x square, and the term which is having x cube. Okay, so in the given polynomial, the terms having x raised to 2 and x raised to 3 are, so what is the x raised to 2 term? It is 6x square, and the term that is having x raised to 3 is minus 3x raised to 3 respectively. Correct? Respectively. Fine. Therefore, the coefficient of x square is 6. Okay, and the coefficient of x raised to 3 is minus 3. Okay, so please be careful about this negative sign. Whenever there is a negative sign, we have to mention that negative. Okay, fine, so be careful of that. Okay, that is why here we have specifically mentioned that it is minus 3. Okay, chalo, now let us go to question number 4. Okay, question number 4. In question number 4, what are they saying? What is the coefficient of z in the polynomial 4z raised to 3 plus 5z raised to 2 minus 11? Okay, so here we can see that the variable z, there is no term having z, only z. We have z cube, we have z square, but we don't have z. So here we have to write this polynomial with the term z. And how can we do that? We can write it this way. See, 4z raised to 3 plus 5z raised to 2 Now the z term is missing, so that we can write with the coefficient 0. 0z, okay, minus 11. That way we can write it. Okay, so here we have written the missing term, and whenever we have to write such a missing term, the coefficient will be 0. Okay, so now here we can see that the coefficient of z is 0. Okay, fine. Chalo, now let us go to question number 5. What is the constant term of the polynomial 9x cube plus 5x square minus 8x minus 10? So here constant term means what? The term which is not having the variable, because that is the term whose value will never change. Otherwise, the terms which are having some variable, as the value of the variables will change, the value of the term will also change. So it will not remain constant. So here in this polynomial, we can see that out of 4 terms, 3 terms are having variable, and only minus 10 is without a variable. So that is the constant term. Okay, fine. The term minus 10 is the constant term, okay, as it is not having a variable with it. Okay, fine. Actually this minus 10 we can also write it as x raised to 0, because we know that x raised to 0, whatever number we have where the power of that number is 0, then the value is 1. Okay, so 1 multiplied by minus 10 will remain minus 10, its value will never change. So that is the constant term. Okay, so see this minus 10 x raised to 0 we can write as minus 10 multiplied by 1, because x raised to 0 ka value will always be 1, so it will remain minus 10 only, it will never change. So that is why it is a constant term. Okay, so with this we have solved all the questions of exercise 2.1. Exercise 2.2, this is the first sum. Find the value of the linear polynomial 5x minus 3. So that is the polynomial given, 5x minus 3. It is having 2 terms. First term is 5x, second term is minus 3. If x is equal to 0, second case is x is equal to minus 1, and third case is x is equal to 2. Okay, so let us solve all the cases. Fine. When x is equal to 0, fine, the value of polynomial 5x minus 3 is equal to, what we have to do, wherever we have x we have to take the value 0 here. Okay, so that will be 5 multiplied by 0 minus 3. So 5 multiplied by 0 will be 0 minus 3. So 0 minus 3 will be minus 3. So that is the value of the polynomial. Okay, let us take the second case. When x is equal to minus 1, the value of polynomial, okay, so we have 5x minus 3, so that will be equal to 5 multiplied by minus 1 minus 3. Okay, so 5 multiplied by minus 1 will be minus 5 minus 3, so minus 5 minus 3 will be minus 8. So that will be the value of the polynomial. And now let us take the third case. When x is equal to 2, the value of polynomial 5x minus 3 will be 5 multiplied by 2 minus 3. So 5 multiplied by 2 will give us 10 minus 3. So 10 minus 3 will give us 7. So that is the value of this polynomial when x is equal to 2. Okay, pretty simple this, right? Chalo, now let us go to the next question in this exercise set 2.2. Find the value of the quadratic polynomial 7s square minus 4s plus 6 if s is equal to 0, s is equal to minus 3, s is equal to 4. So here also we have 3 different cases. Okay, so let us take the first case. When s is equal to 0, the value of polynomial is, let us say, is 7s square minus 4s plus 6. So the value of this polynomial will be, now in place of s we have to take 0. So 0 square minus 4 multiplied by 0 plus 6. So what will that give us? So 0 square is 0, okay, minus, now 4 zeros are 0 plus 6. So now here also 7 multiplied by 0 will give us 0, and minus 0 plus 6 will give us 6. So the final answer will be 6. Okay, fine. Now let us do the second one, the second case, when s is equal to minus 3. When s is equal to minus 3, the value of polynomial, the value of polynomial is, so let us write the polynomial first, 7s square minus 4s plus 6. So now s is equal to minus 3. So that will give us 7 multiplied by minus 3 the whole square minus 4 multiplied by minus 3 plus 6. Okay. So now 7 multiplied by minus 3 ka square will be 9, not minus 9. Many students will make the mistake. Minus 3 square will be minus 9. No. Minus 3 multiplied by minus 3. So minus minus becomes plus. So it is 9. 4 multiplied by minus 4 multiplied by minus 3 will give us plus 12 plus 6. Okay. So now 7 multiplied by 9 is 63. 12 plus 6 will give us 18. So 63 plus 18. So 3 plus 8 is 11. 1 carried. 7 plus 1 is 8. So it is 81. The value of the polynomial is 81. Okay. So now let us take the third case. Okay. In the third case, the value of s is equal to 4. So when s is equal to 4, the value of polynomial, the value of polynomial is, what is the polynomial? 7s square minus 4s plus 6. So in place of s we will have to take 4 now. So 7 multiplied by 4 square minus 4 multiplied by 4 plus 6. So 4 square is 16, minus 4 multiplied by minus 4 will give us minus 16 plus 6. Okay. Now 16 sevens are, so 7 6 are 42, 7 ones are 7 plus 4 is 112. So 112. Now minus 16 plus 6 will give us minus 10, and minus 112 minus 10 will give us 102. So the value of this polynomial will become 102. Okay. So friends, that is the answer of question number 2 from exercise 2.2. Okay. Now let us go to question number 3 in this exercise. So here it is actually a word problem. The present age of Salil's mother. Okay. So we are talking about a person called Salil. His mother's age, present age, is 3 times Salil's present age. After 5 years, their ages will add up to 70 years. Find their present ages. Okay. So here, friends, the trick of solving these sums or word problems is that whatever we are asked to find out, we will take it as the variable. Okay. So here we can take the present ages of Salil and his mother as a variable. Okay. So here we can see in the first statement they are stating Salil's mother's age in terms of Salil's age. So that is why we will take Salil's present age as x. Okay. So that will be our first step. Let Salil's present age, let Salil's present age be x years. Okay. So if Salil's present age is x years, then the present age of Salil's mother is 3 times of that. So 3 times means multiplied by 3. So x multiplied by 3 will be 3x. Okay. So present age of Salil's mother will be 3 times of Salil's age, that is 3 times of x. So it is 3x years. Okay, 3x years. Fine. Now let's look at the second sentence. After 5 years, their ages will add up to 70 years. Okay. So after 5 years, what will be the ages of Salil and his mother? So his present age is x. Now after 5 years means we have to add a 5. So after 5 years, Salil's age will become x plus 5. And the age of Salil's mother will become 3x plus 5. Okay. So after 5 years, Salil's age will be x plus 5 years. Okay, and his mother's age will be 3x is her present age. So after 5 years it will become 3x plus 5 years. Okay, so what information are we having in the sum? That after 5 years whatever their ages are, they will add up to 70 years. Add up to, that means their sum, their addition will be 70 years. Okay, so therefore according to the given condition, now we are going to get a equation. Okay, so what will that equation be? Adding Salil's age and his mother's age after 5 years will be 70. So that will give us x plus 5, which is the age of Salil, plus 3x plus 5, which is the age of his mother, will be equal to 70. Okay, so this equation we get. Now let us simplify this equation little. X plus 3x will be 4x, 5 plus 5 will be 10, is equal to 70. Okay, so now we simply have to solve this equation. We get the value of x. Okay, so for doing that, we can see here on the left hand side there are two terms. One is a term with variable 4x, another is a constant term. So let us take this constant term on the right hand side. Therefore 4x is equal to 70, and this plus 10, when it goes on the right hand side it will become minus 10. So therefore 4x will be equal to 60. Therefore x will be equal to 60 divided by 4. Here it is 4 multiplied by x, it will become, so on the right hand side it will become division, 60 divided by 4. Okay, so therefore x ka value will be 15. Okay, so we got the value of x, that is 15. Okay, so x is what? Salil's age. Okay, so x is equal to 15, therefore 3x will be equal to 3 multiplied by 15, that is 45. Okay, so we got the ages of Salil, that is x is equal to 15, and we got the age of Salil's mother, that is 3x is equal to 45. Okay, so simply we have to write it in statement. So the present ages of Salil and his mother are 15 years and 45 years respectively. Okay, so that is the answer of this question number 3 of exercise set 2.2. Okay, chalo, now let us go to sum number 4. Okay, in sum number 4 we are talking about another word problem. The difference between two positive integers is 63. The ratio of two integers is 2:5. Find the two integers. Okay, so here we are talking about two integers. So they can be negative numbers, they can be positive numbers. Okay, so we can take those as the variable. जो हमको ढूंढना है, that will take as variable. Here this second sentence will help us write the variable, the terms with the variable. The ratio of the given integers is 2:5. Okay, so that means they will have some common multiple. So that will be our first step. Let the common multiple be x. Okay, it should be b, not by. B x. Okay, whenever we are given a ratio we can follow this method. Let the common multiple be x. Therefore the two integers in ratio 2:5 will be 2x and 5x. Okay, the two integers will be 2x and 5x. So we got the two terms which are required for making the equation. Now we will use the condition given in the first sentence. The difference between two positive integers is 63. Okay, so when we are subtracting the smaller integer from the greater integer, we will get 63. Okay, so out of 2x and 5x, which will be the greater one? 5x will be the greater one. Okay, so therefore according to the given condition, comma 5x minus 2x, we are subtracting the smaller positive integer from the greater positive integer, and the difference between them is 63. Okay, so now we have to solve this simply. 5x minus 2x will be 3x. is equal to 63. Therefore x will be 63 divided by 3. Therefore x will be equal to 21. Okay, so here we got the common multiple. Therefore 2x will be 2 multiplied by 21, that is 42. Okay, and 5x will be 5 multiplied by 21, that is 105. Okay, so these are the two integers that were asked for. Okay, so the required integers are 42 and 105. Okay, see, some students will stop here only, x is equal to 21, but that is not the question which is asked. That is only the common multiple which we had taken in the first step. So actually we have to find out 2x and 5x, which we have done finally. Okay, so friends, we have solved the fourth one. Now this fifth one we will continue in the next video.